our have to remember that to manage SPoT. So, and then does the SPoT team want to introduce, and then we could go to the committee members?
Hey, I'm Bushra Khan. I'm a project scientist with the Department of Environmental Toxicology at UC Davis, and I serve as the laboratory director of the Granite Canyon Laboratory.
I'm Katie Stiegler with Granite Canyon. I'm the laboratory manager, and nice to see everyone again.
Hi, everyone. My name's Randy. I'm the laboratory operations manager at Granite Canyon, as well as the field lead.
Bryn Phillips. I don't manage anything anymore, but I advise MPSL on anything they might need.
Okay, could we have our committee members introduce? Maybe start with Jim, because you're the first picture I see.
Hi, I'm Jim Orlando. I'm part of the Scientific Review Committee, and I'm currently the Water Quality Specialist for Research with the U.S. Geological Survey California Water Science Center. Nice to see everybody.
Everyone's so polite. I'll just jump in. Hi, I'm Mary Hamilton. I'm with the Central Coast Water Board, and my background is related to water quality monitoring and specifically related to SPoT program and other things, including QA. I will pass to Kelly.
Hi, I'm Kelly Moran. I'm a senior scientist at the San Francisco Estuary Institute, and I'm absolutely psyched to be here today to support the SPoT program and the Granite Canyon Lab. And it's a thrill to see so many amazing people participating in this meeting, also supporting that program. And a special shout out to Jim Orlando for being a federal employee and sticking it out. So I really want to honor federal employees every time I can.
Thanks, Kelly.
So maybe I'll pass it to either Rob or Ann Cooper from DTSC.
Sure. Hi, I'm Ann Cooper Doherty. I'm with the Safer Consumer Products Program at Department of Toxic Substances Control. Rob?
Also with Safer Consumer Products, Rob Rossi, Senior Environmental Scientist, DTSC. Maybe Alana?
Yeah, I don't know. We have a couple folks from regional boards on. If y'all want to introduce yourself, you can. I know Rob Budd, it looked like he was here, but we heard he is sick and mainly just listening in. So if you're off the hook for introducing yourself, Rob, or I don't know if you stayed on, but otherwise, do regional board folks want to introduce themselves, or? Yes, I could.
Hi, this is Kelly Huck from Region 6 with the SWAMP program.
Thanks, Kelly.
Elena Mexico, Region 6 as well.
Heather Boyd, Region 8.
I see some folks from Region 5. Alicia is here. And then folks from DWQ. Wendy, do you want to introduce?
Yeah, good morning. My name is Wendy Link. I'm a senior engineering geologist. I appreciate being able to listen in. I help manage PFAS in regards to all of the investigative orders in regards to DWQ. Thank you.
Okay, and then I think maybe just Anna Pierik.
Yeah, hi. I'm not technically part of the SPoT program, so I didn't join them when they introduced themselves, but I am the non-target specialist working on their samples. Also, I'm with UC Davis under Dr. Tom Young, and I am representing both of us today.
Awesome. Thanks, everybody. It's a good group here. Okay, I think we can pass it over to Bushra if you want to get ready to get started.
Yeah. Well, thank you everyone for joining. I am thrilled to be giving this presentation, summarizing all the updated trends, showing everyone what we have been doing. Thank you to all SRC members for being here, for your time, and we hope to seek some guidance and recommendations for the future of the program and get inputs on our monitoring design. So let me know if you can see that. Everyone can see the next slide, right? The agenda slide.
Looks good.
Yes.
Okay, great. So there are 6 big sections for the presentation today. And there is a break built in after the third one. So in the first half of the meeting, I am going to be updating everyone on the historical trends, as well as the work that we have done with our non-targeted analysis workflow. And then we'll break for 10 minutes. And then when we come back, we will start with the monitoring plan and budget discussion and some larger discussion questions, address some larger discussion questions for the program, take questions about trends and NTA work that we have done, and go into, after that, collaboration deliverables, presentations, that discussion, and finally wrap it up. My challenge, as always, is not to ramble and stay on time. I have a clock in front of me, but if I am not sticking to time, Tessa can probably help me get back on track. Okay, so this is a table that we show every year. We are currently in the 18th year of SPoT monitoring program, and this slide summarizes the history of analyses that have been conducted for the program. So the top row here lists the years, below which is the number of sites we visited for that year. The first column in blue lists all the different kinds of analyses with toxicity in the first 2 rows. So for just to jog everyone's memory, for toxicity testing, we use the amphipod Hylela azteca and the Mitch Chironomus dilutus. So Chironomus, as you can see here, was added later to the program to capture toxicity of some analytes that the Mitch is sensitive to. And all of these data have been used to conduct temporal trend analyses. Out of the 90 SPoT sites, we have 40 that are categorized as urban or tier 2. And some analytes, as listed here in the blue column, they are historically have been measured on at the tier 2 urban sites. The red crosses here indicate data that have not been used for trend analyses due to QA concerns. Some example of that are the 2019 OC and PCB dataset. And some of these datasets were not included in the trend analysis because of having a disproportionately large number of non-detects. I said this last time, the most recent addition to the analyte group is PFAS. We have 4 years of data, out of which only 2 years, 2023 and 2024, have been used for trend analyses because we had some QA concern for 2021 and 22 data sets. The following slides will show the most updated historical trends. The trend analyses that we conduct are conducted using Mann-Kendall method, which is a non-parametric statistical test that identifies trends over time. It is a very useful tool in monitoring because it doesn't assume how the data are distributed or what time period over which they are collected. This test also handles missing data fairly well or irregular sampling periods without skewing the trends. Using these statistical analyses, we have identified site-specific trends and statewide trends. And the method that we are using, just very briefly, it assigns a statistic to a series of sampling events by providing a score to the differences between sequential sampling events and calculating a sum of those scores. So broadly, it categorizes the data into either upward or downward trend or stable or no trends. Now, the upward and downward trends are subcategorized into broad categories of probably upward or probably increasing or probably decreasing. And that distinction between probably or actually increasing is just based on a confidence factor. So if the confidence factor is between 90 and 95, it's probably, and if it's 95, between 95 and 100, it is either increasing or decreasing. The stable and no trends, that is distinguished based on how much noise or scatter there is in the data set. So if between different sampling events, sequential sampling events, there is a lot of up and down, a lot of noise and scatter in the data points, the method identifies it as no trend. But if the coefficient of variation is low, it defines it or categorizes as stable. So the site-specific trends that we generate, they are used to generate percentages of sites with different trend categories that I'm going to be showing for several different analyte classes in the following slides. And the statewide medians are calculated annually for each analyte, and trends are identified using these medians over time. We discussed in our last SRC that the statewide trends do change based on the spatial scale. So if you're only going to 90 sites versus 40 sites and using 90 versus 40 to generate that statewide trend, it can change. So we can have a discussion later what these statewide trends mean for a state as large as California, and what is the scale of these, what should be the scale of these trends. So I'm going to jump into our toxicity data set spanning from 2008 to 2024. The toxicity markers are, as you all know, excellent screening tools to prioritize monitoring at the sites with impacted marker response. The charts here show percentages of sites with different toxicity trends indicated by different colors. So the tan and orange tan and orange indicate elevated toxicity and green indicate declines in toxicity. The toxicity trends are identified using two species, the freshwater amphipod, as I mentioned in the first slide, Hylela steca, and midge, the midge larva, Chironomus dilutus. The two toxicity markers that were utilized here would decrease survival and growth to identify toxicity for each species. So in this case, on the very first pie chart that you see is Hylela mortality. A total of between the tan and the orange wedges, 9 sites were found to be increasing in toxicity. And 10 sites were found to be decreasing in toxicity based on the Hylela mortality marker. For Hylela growth, between the bright orange, which is listed as 16%, and the tan listed at 9%, a total of 22 sites were found to be increasing, and only 1 was found to be showing decreasing trends of toxicity. As you can see, there is a large proportion for Hylela and Chironomus, both of these, all of these 4 pie charts with gray wedges showing stable or no trends. For Chironomus, which is shown on the right of the slide shown currently, we have 4 sites with increasing trends as shown in that bright orange, and 4 sites with decreasing trends. And for growth, we have 15 sites with increasing trends shown as the greens on the last pie chart. I just want to make a note here that Hylela toxicity is measured at all 90 sites that we visit, and Chironomus toxicity is measured at 60 sites. So the 2024 data set was very, very interesting, and 9 sites were identified as toxic using the Hylela survival as a marker, which is the first chart, first bar on the first graph. Out of those 9 sites, 6 were highly toxic and 3 were found to be toxic. But with the addition of the growth marker, which is the second bar on the first chart, 28 unique sites were identified as toxic. And out of all the sites which were identified as toxic using Hylela growth, 5 overlapped with the survival marker. So the total number of sites identified as toxic based on just Hylala growth was 33, 28 out of which were unique. So this represents the value of Hylala as a model for SPoT, as well as growth, a value of the growth marker as a sublethal marker, which is adding value to toxicity testing. On the right, you have another graph which shows that addition of another organism, which is Chironomus dilutus midge larva at 60 sites, uniquely identified 3 sites as toxic, and there were 6 overlaps between Hylala and Chironomus toxicity data. And when we add a marker or when we add an organism to the toxicity testing profile or suite of information or suite of markers that we are measuring, the identification of unique sites is often very attractive because we want to find more toxicity with more markers and with more organisms. But I would also like to argue and note that the results, overlapping results between toxicity markers between organisms are as notable and as valuable because what they are indicating is a complex mix of chemicals that these organisms are being exposed to. Because both of these organisms have varying sensitivities to different contaminants. So if there is overlap between Chironomus and Hylala toxicity data that we get, then it is indicative of a complex mix of chemicals in the environment. And the same goes for the growth marker. It is very important because it's showing sublethal responses. Statewide, for Hylala mortality and growth, we have urban land use correlation that we showed last time. Those are still the same correlations with the inclusion of 2024 dataset. No trends or stable trends were found for all for both species, all 4 markers. And for Chironomus, we don't see much in terms of land use correlations, but again, going back to the previous slide, Chironomus does add value by identifying some unique sites. These heat maps have been shown last time, and I've included 2024 data on these. And these heat maps, they're broken into 2 tables just for visual convenience, but what they show is the data from the Hylala mortality marker, and is divided into 3 broad categories. So the green is good, basically not toxic, yellow is toxic, and red is highly toxic. Sites are divided into 2 tables, as I mentioned, and they're sorted by region. And the first column for both of these tables lists the sites, and the last column for both of these tables lists the trend. So if the trend is going up, there is a black up arrow, and if it's going down, there's a down red arrow. So the point of showing this is that some sites stay non-toxic through the entirety of the program. And we mentioned in the last SRC that there may be value in putting some of those sites on an every other year, alternate year cycle, which is something that we are doing starting this year. But there are some sites which have consistently stayed toxic, and there are some sites which are very interesting because they go up and down in toxicity. So it is important to look at the toxicity data as a broad screen for site selection, and to look at candidate sites where we may not know what is causing the toxicity, and further investigation and new tools and techniques may be required. Okay, so jumping into our targeted chemistry data sets. And so in 2023, so I'm going to start with pyrethroids. In 2023, we collected pyrethroid data for 40 sites. And the data are shown here as pie charts reflecting trends between 2010 and 2023, only for those 40 tier 2 urban sites. As expected, the trends shift slightly when the spatial scale is changed from 90 sites to 40 sites. So last year, I showed you data for 90 sites. But the overall patterns, when you compare those 2 data sets, are similar. So bifenthrin is increasing at 14 sites, which is represented in the first pie chart here as the bright orange, and 10 wedges showing 35%. And it's decreasing at 4 out of those 40 sites. It's the same message that we got from the 90 site data set that I shared last time. Delta methrin is also increasing at 12 sites, which is 25%, and decreasing at 3. For the remaining pyrethroids, most sites showed no increases or minimal increases, and some pyrethroids were increasing. Some of the pyrethroids of all these pyrethroids were increasing at 1 site and decreasing at 15. So moving forward, we plan on measuring pyrethroids at these 40 sites in 2025 to track these changes at this scale. And in our discussion later, we can consider how we select those 40 sites. Do we only want to go to the 40 urban sites, or do we want to have selected urban sites with upward or downward trends, and also include some agriculture sites where there may be trends from a historical data set. Statewide, using these 40 sites, 3 pyrethroids were found to be decreasing, and rest showed stable or no trends. And of course, we're going to continue monitoring these trends. No significant relationships were identified with land use using these 40 sites. As presented in previous SRC, our long-term data set, which included 90 sites from between 2010 and 2022, that showed, and I shared this in last meeting, pyrethroid toxic units increasing statewide and significantly related to urban land use. These trends and their relationship with amphibious toxicity have been assembled in a manuscript, which is currently under review and hopefully would be accepted and available soon. So, as I mentioned on the previous slide, it is important to track pyrethroids at some sites on a temporal scale, but the scale of the pyrethroid monitoring can be adjusted to make space for other contaminants. I mean, I think we have told the pyrethroid story for the state and have identified meaningful relationships. So moving forward, it is important to decide what should be the frequency and the scale of these analyses. And I know that we have had a discussion last time that the sites that are important to DPR, those will be included, and wherever there are TMDLs for pyrethroid, those also need to be included. So that's a larger discussion that we need to have for site selection for pyrethroids. Another thing that we have done for pyrethroids is in 2024, we have started creating some GIS visualization with the help of one of our team members. And these maps on the left show median bifenthrin and pyrethroid toxic units on the right, which a toxic unit represents the potential of toxicity for that analyte, in this case, pyrethroids, based on the LC50 values. So we are also plotting other maps for trends, such as the one shown here for bifenthrin. And the goal of creating these visualizations is to use them on our website or on a fact sheet to summarize long-term trends on a spatial scale. And we can talk about this again when we discuss that, how these visualizations can inform fact sheets or summaries for each analyte at regional or state scale. Moving on to fipronil. Fipronil and its degradates were last measured in 2023, and they will be measured again this year in 2025 at 40 tier 2 sites with urban land use. Most sites show stable or no trends for fipronil concentrations. Fipronil is increasing in the first pie chart, that bright orange wedge. It's increasing at 5 sites, which makes it 12.5% of the total number of sites that we visited. And the sum of the fipronil, which is at the bottom pie chart, is decreasing or probably decreasing at total of 11 sites, representing 28% of the 40 sites that were sampled. Again, just like pyrethroid, fipronil is important at urban sites and should be tracked, but it can be put on a temporal cycle, longer cycle at selected sites. And we'll talk about that later when we visit our monitoring plan. With the inclusion of 2023 dataset, the statewide trends show no trends for fipronil and its degradase except for fipronil sulfone, which is decreasing. No significant correlations were identified with land use, and inclusion of 2023 data has changed some of these trends because for the 2022 dataset, there were trends found for desulfonal and sulfite trends. So it is important to continue to track because just last year data or 2023 data changed some of these relationships. In 2023, we also measured PCBs at 40 sites and identified total of 7 sites with increasing and 5 with decreasing trends. And just to jog everyone's memory of the older trends shown here on the right, between 2008 and 2022, PCBs were measured at 90 sites, identifying 3 sites with increasing trends. The land correlation remains the same. So this just goes on to show that moving from 90 sites to 40 sites for PCB was the right decision. Based on our discussion in our last SRC, we decided to put PCBs on a longer 5 to 10, but right now it's on 5-year cycle, and only focus on some hotspots where the trends, historic trends, were going up or down. The next cycle for PCB is 2028. Similar to PCBs, in 2023, we measured organochlorines at 40 sites, chlordane and DDT shown here. For these sites, chlordane and DDT showed either stable or not stable, just no trends. And chlordane was increasing at 2 sites and decreasing at 4, and making 5 and 10% of the total number of sites analyzed. But the main lesson here, or main message here, is most of the sites show no or stable trends. And again, same discussion as PCBs last year, organochlorines are going to go on a much longer temporal cycle for monitoring and will only be monitored at hotspots where there were increasing or decreasing trends. Next up is PFAS. As we discussed in our last SRC, the first 2 years of PFAS data were not the greatest quality. So we have taken 2023 and 2024 data sets to make some comparisons. We have 2 years of data. We need another 2 years before we can start building trends using Menn-Kendall analyses. However, we already are seeing some patterns that I'm going to describe in the next couple of slides. So the data we have is for a set of 40 PFAS measured using EPA 1633. That list of compounds is measured at 40 tier 2 sites shown here. This particular graph shows on y-axis the percent of sites each of those 40 PFAS compounds were detected. No big surprises here. PFOS, which is the 8-carbon chain sulfonic acid, was found at the highest was detected the most, and followed by PFOA, which is PFOA, which is also the 8-carbon chain PFAS, but it's the carboxylic form. Those are the 2 most detected PFAS compounds. But what is also notable here is the longer chain carboxylates, C10 to C14, were also widely detected at these tier 2 urban sites. These C10 to C14 PFAS are very persistent and very bioaccumulative, and it would be interesting to see how these detections change, if at all, over next few years and beyond. Another way to look at percent detections is to calculate how many PFAS out of the list of 40 are detected at each site. So for this graph, you see on the x-axis all the sites listed, and on the y-axis percent PFAS detection, which shows how many out of this 40 are detected. We see similar results for most sites between 2023 and 2024, and some notably toxic sites with have complex PFAS profiles, which I will show in the next couple of slides. This slide shows percent contribution to total PFAS in 2024. So some PFAS compounds are more ubiquitous than others and are found across sites. So the bright red that you can track from left to right, that is PFOS, which is that 8-carbon chain sulfonic acid. And that was detected at 36 out of 40 sites. Last year, it was found, or the year before, 2023, it was found at 35 sites. So it really checks out year to year. The suite of 40 PFAS compounds that we are measuring that includes legacy PFAS such as PFOS, PFOA, and other carboxylic and sulfonic acids, as well as some novel or alternative PFAS that are advertised as safer options. But overall, several urban sites showed complex mixture of PFAS and sediments, and the graph on the right shows 3 with the highest sum PFAS, which I'm going to elaborate in the next slide. So the 3 sites which had the highest sums have 2 overlaps between 2023 and 2024. And I am using here the example which was only identified with high sums in 2024. This is a site in Region 4. It's Bouquet Canyon. This is a site that has significantly higher concentration in 2024 compared to 23. So the higher detections that you are seeing and higher concentration is represented on the pie chart, which is on the right, which shows a more complex PFAS profile. So these changes in profile at sites which are toxic and sites which are expected to have a lot of different kinds of PFAS, it's important to track that in the next few years. The top 3 sites with highest number of detections did not change between 2023 and 2024. And as expected, they are the sites which are toxic and which are expected to have a complex PFAS fingerprint. I do want to mention that the PFAS are not present at these sites as toxic levels, but the sites themselves are toxic due to other contaminants. Out of the 3 sites which are listed as highest percent detections, I have shown how complex those PFAS profiles are, and it was interesting to see that these 3 did not change much from 23 to 24. I'm going to go really quickly through a couple of analytes that we are not monitoring right now. I will come back to PAH discussion when I talk about NTA. The data that I'm going to show for PAHs and in the next 2 slides for 2 other analytes have been presented in the previous SRCs. So PAHs are measured at 40 sites, and between 2010 and 2021, listed here, that between 2018 and 2020, these data were affected by some data quality issues. So those data are not reflected in the analyses I'm showing here. Some of PAHs, which is the last pie chart on the right, that was found to be increasing at 10% of the sites, which is just 4 sites out of the 40. And overall, most urban sites have stable or no trends. And again, we'll come back to this in our NTA discussion, but PAH is no longer on a cycle for our monitoring design. Same goes for PBDEs and OPs here. This slide you have also seen before. For some PBDs that were measured at tier 2 sites, there were no significant statewide trends and only a handful of sites increasing or decreasing. Same goes for organophosphates. So if there are specific interest or questions, regional or statewide, that need to be answered for these 3 analytes, we can discuss what those data needs are and what kind of data need to be generated. But for now, these are what I call retired for our design. Finally, the metals data was most recently analyzed in 2024. We are measuring a suite of 5 metals. The metal trends were identified at 90 spots. Here you see pie charts representing data collected between 2008 and 2024. Copper is very important for our last SRC discussion, so is zinc. And moving forward, we can maybe focus on sites with increasing or decreasing trends, or only focus on tier 2 sites for copper to track the changes and implement the effects of the copper brake pad law. And if there are other metals which are of interest in addition to copper, I remember zinc was also mentioned last time, we can talk about it in our discussion. Statewide, we are seeing some changes in trends for metals. We see decreasing trends with the inclusion of 2024 data set. So cadmium, copper, and lead are either decreasing or probably decreasing. And some of the correlations have also changed. So right now, the correlations that I'm showing with the inclusion of 2024 data are urban and agriculture for only lead and zinc. So that is the end of the targeted data set. I think I finished early, so we have more time to talk about non-target analysis, but I think this is a good point to stop and go back to any slide if there are burning questions right now, or we can take all the questions after the break in our discussion. Anyone wants to go back to any slide?
Yeah, I had just a couple of questions. There's been a lot of controversy around the high-level growth endpoint. I think it's mostly about water, for like whole effluent toxicity for wastewater. And I was just wondering if you had any comments about your confidence in the high-level growth endpoint and your tests on that.
So we have had more variability in chrononymous endpoint. The high-level endpoint, I would say, is pretty solid. The standard deviation, standard errors that we are looking, they're not high. I don't see any concern with that. And of course, year to year, it changes, not the confidence, but the data set changes. And this year, we just found more sublethal responses. So the way we measure growth, and also some of the checks and balances that we have put in place to make sure the dry weight is as dry as it should be, all of that makes me very confident in that data set. But
Cool.
if there's anything else that you want to bring up or from other folks, then we can chat about it. I don't see a problem with the high level growth endpoint. The chrononymous is difficult just because of the variability.
Yeah. Now I was expecting you would say that. I think a lot of those issues are lab issues, and your lab has so much experience. So I'm not as worried about that. I'm super excited about the pyrethroids manuscript, and I'm so glad you guys are getting that into print. I'm wondering if you were you able to access any sales or use data as part of that analysis, or
for the manuscript you said?
yeah, or for this work? Yeah.
No, like gross big, like in the introduction, there are just the gross big comments, but no, nothing that we did with sales or use data to generate in the context of our work to make any direct connections.
Yeah. I know Rob is probably not in a position to comment, but it is one of my curiosities is I've been kind of hearing rumor that that pipe conference actually increased in urban market share, and that some of the things that you're seeing are having to do with changes in sales and use of various products. And that's kind of a question out there. I'm disappointed that we're not seeing some of the responses we were hoping we would see as a result of the mitigation measures that DPR implemented. I mean, now it's been, that was 2012, so it's quite a long time now. So that's disappointing and something that gives me pause. And I know DPR has a ton of stuff on its plate, so I'm not going to suggest that this be the highest priority, but more that it seems like there's some questions there that need to be addressed. Figure out what's going on, and your role is really important in that. So thank you.
Thank you.
Kelly, thanks for bringing that up. I totally agree. That's super important. Fisher, I have a couple of questions, but they're going to be related more to like the prioritization of the monitoring design and budget discussion. but I'll want to refer back to some of the slides. I'll just hold it, but unless you'd like to.
I think the budget discussion and the prioritization and site selection is a discussion that can wait. It's better to wait after I show some other data that we have generated using NTA, because it's part of the bigger similar discussion. But if there are like any technical things or any slide that I went too fast or anything comes up that looks like that it needs further explanation, I'd be happy to do that right now.
No, none other than flagging for Wendy. You'll be hearing from me. I have some questions about the data at one of my sites, just like geeking out on like the PFAS piece and why certain things are where, but not related to SPoT.
And I just wanted to say I appreciate the couple map slides you included in the presentation. I see those weren't in the version that was sent out by email, but I appreciate those as a map guy. I'm always during these meetings, I'm always got ARC open on the other screen. I'm trying to map where some of these sites are and just seeing what's going on. So I appreciate that. And I think that's useful for our discussion.
Thank you. Yeah, the map work is one of our team members, Kat Molinari, and she has done a lot of work with GIS mapping now. And so it's really cool to see these visualizations. We've created these maps from several different analytes, and I really think it's a cool tool to have on our fact sheets that we are slowly but surely working on. And it also is a good tool to have on our website just to create these visualization for large data sets. So we'll continue doing that. Thank you. Anyone else? Okay, so I'll move forward with the NTA. So NTA work that we have done since 2021, not continuously, but there was 1 year of no NTA data since that, and I'll show what have we done. I'll summarize it in a table. But we made a lot of progress from where we started on our non-targeted analysis workflow. All the NTA work is in collaboration with Tom Young's laboratory, UCD main campus, and Anna Furyk, who is in the audience, is the main lead on analysis and explaining all things analytical chemistry to me. And so we have had some time to sit with these data and to consider the best way to integrate non-targeted analysis into SPoT's design to, one, better address the management questions, and two, to augment the data set that we already have. So the idea here is to how NTA can add value to our specific management questions and the design that we have. So in this section of the presentation, I'll present examples of how these data can add value to SPoT, and I'll try to define what the SPoT NTA product could look like. And then we can have a broader discussion about how to really fine-tune that into a meaningful component of the program. Okay, so I'm gonna go really quickly through what our current NTA workflow is, just to jog everyone's memory. So this is Randy Barton. This is our field lead, who is also in the audience. So we collect environmental samples and they go through a series of different toxicity tests. And the example that I'm using here is amphipod Hylola esteca, because that is what we have been using for our NTA work. So we are already conducting these or generating these toxicity data, and the entire NTA workflow right now leverages the data that SPoT is already producing. So on the same sediment, you can have extractions conducted where you have the NTA extracts that is analyzed later on using LC and GC high-res mass spec, and it can be library meshed to identify different features. But as you all know, NTA creates and generates so much data to parse out what is relevant to our program or to any research or question or specific management need. You need an anchor, and that anchor is our Hylola data set. So we used a prioritization model that is developed by Tom's lab. And we use spearmint rank correlations that are drawn using peak heights and toxicity markers. And what that gives us is it has helped us to think ways to meaningfully make a product that can be integrated. And that product, the way I think of it, it has two branches. The first one is the prioritization of chemical features. The second one is use of commercially available standards for quantitating contaminants of interest. The second one is more of an extension, I would say, because that is something that when we started that pilot in 2021, we agreed upon during that collaboration on a list of 70 standards that was assembled in 2021. And those standards can be used to generate quantitative data, similar to how you would generate quantitative data using a targeted workflow using a standard curve. And I know there was a large discussion last time, I'm sure it will happen this time as well, on QA/QC. We have already put together documents of QA/QC for both of these branches. We'll talk about that later. So for the first branch, for the prioritization of chemical features, what NTA can provide is a list of chemicals that can inform SPoT about contaminants of interest at statewide or regional levels or within the context of land use, all of which are relevant to the management questions that we currently have. And for the second branch or extension, which is our more quantitative branch, the initial list that I just referred to, that included several classes of pesticides and pharmaceutical and personal care products. And the initial list also included analyze that I have just shown you data for. So it includes pyrethroids, it includes fipronil. So just to broadly categorize these two branches, the first one is qualitative, the second one is quantitative and comparable to the commercial lab results. And I'll just say it right here, and I'll probably say it 5 more times during the course of this presentation. The quantitative branch is not to replace targeted chemistry completely, the way we run it with the commercial lab contract right now. What it could do is it can fill in the gaps for targeted chemistry once the QA/QC is approved and once I show that these numbers are robust and accurate, or robust and useful. We can use the quantitative data to fill in the gaps for targeted analytes for years that the targeted chemistry is not planned, or for sites that we are not visiting that year, so that we have a continuation of the trends and we can keep our finger on the pulse. So I'm going to very briefly describe what we have done in terms of number of samples so far for NTA. So this slide shows a summary of the work conducted on SPoT sample using different collaborations. I will point out though that through different collaborations which have been able to leverage SPoT's network of sites, we have done a lot of non-targeted analyses, but the goals of all those different collaborations were different. They were not the same as the SPoT management question. But because we were generating NTA data, it allowed us or gave us the opportunity to look for trends and look for comparisons that are important to discuss if we are to integrate this in a meaningful way within SPoT. So for year one in 2021, that was the first time we did anything with NTA for SPoT. So we did this pilot with 30 samples in collaboration with Tom's lab. That is when the prioritization model was developed to identify drivers of toxicity. Year two of NTA there was a break. In 2022, we had no NTA work done in terms of collecting samples. We were working with data. But in 2023, which is year two of NTA, we collaborated with the CEC program of the Division of Water Quality and continued our work with Tom's lab. 18 sites were selected for this year, and they were analyzed with the same prioritization workflow, but we added more markers of toxicity. Year three was 2024, which was last year, which thanks to Rich Fadness, Region 1 supported our non-targeted work, and we sampled total of 18 samples, 6 from Region 1. So all of SPoT Region 1 sites were analyzed for NTA. And in addition to that, we have 12 other sites from other regions. And this site selection was very strategic because we wanted to build a larger NTA data set. So a lot of sites that were identified, that were analyzed in year 2 in 2023, we added that for our 2024-18 N of 18 data set. And year 4 would be this year, because this in 2025, we are expanding in our year 2 NTA work into our year 2 of CEC collaboration. So we have selected 12 sites to build upon the CEC work that we did in 2023. This is a table of all the sites that have NTA data, and on each of these columns show the years that this work was done in, and anything highlighted in that orange is the orange highlights represent the sites for which we have 3 years of data, and all the orange highlighted sites will also have data from 2025. So just to summarize the 2021 results, the 2021 results right now are being assembled in a manuscript, the lead of which is Anna Furick. And we have worked very hard and looked at that data set from many different angles, and hopefully that'll be submitted in the upcoming month and would be available. But I'm going to only show the pieces which are relevant to SPoT, just to give a very brief overview of our pilot. So the first thing that we learned from our pilot using the non-targeted analyses is no surprises that as the urban land use increase, your number of features that we found in our NTA workflow increased. So no surprises there. In more urbanized area, you would expect many different chemicals in the sediment. The second was we found the complexity of chemical fingerprint. I don't want to go into too much detail. We can talk later or offline about what data went into creating these PCAs, but I thought it was relevant to show these principal component analyses, because last time in the SRC, there was a question that came up in context of high-level toxicity between Region 2 and Region 4. And there was a question about why are we not seeing similar toxicity patterns in Region 2? And my answer to that was because likely it's a different chemical soup. We know that from targeted chemistry, but we also now know that from non-targeted analysis. So just very quickly on these PCAs. So all the circles that you show are sites in urban areas, which are listed in that red font. So for example, on the first PCA on top, you see 2 Region 4 sites, which are very different in their chemical fingerprint from the San Leandro Creek, which is Region 2. So that's on the left. On the right, on the left, you have all the features related to mortality of Hylella, and on the right is growth. And growth shows basically the same thing, that different urban areas that we have toxic sites in the SPoT network of site, they just have a complex and different diverse chemical fingerprint. None of these 2 things are shockers. I think we anticipated that, but it is there is power in seeing that from a non-targeted perspective. And finally, we found through several different kinds of analyses that bifenthrin is a major driver of toxicity. There is a lot of work that Anna has done on the prioritization model and has presented and assembled that in that manuscript in a really cool, informative way. But I will leave that piece out for now. But it was so in 2021 with 30 samples, which is just a subset, a third of 90 sites, we were able to identify bifenthrin as a driver of toxicity, which is the same result that we found during like first 5, then first 16 years of the program using targeted chemistry data. So this is a validation that the prioritization model is able to find the drivers of toxicity relevant to the program. Okay. This is a slide that I showed last time, so I'm going to jog everyone's memory because I'm going to talk about the quantitative part of the NTA product first. So last time we talked about the 30 samples that were analyzed in 2021, and I showed comparisons between the targeted chemistry data from the commercial lab, which is for every contaminant listed here, the first column, and the second one is NTA. I've just listed it as an NTA, but that is also a quantitative workflow of the current NTA work that we are doing. And everything grayed out here was estimated concentrations from the commercial lab. Everything in blue checks out fairly well, robust comparisons. I have also highlighted some cells here in red to show that there may be differences in between comparisons here and there. And we just want to assign the level of confidence and the comfort we have in some of those minor differences. So this was 2021. We wanted to do that again, of course. And we before we go into 2023, for fipronil, I want to also note that for 2021 data set, we got no measurements except 2 from our targeted chemistry work. So that was a complete loss in terms of any concentrations that we could use to build trends. From our non-targeted quantitative side of that workflow, we were able to quantify fipronil and degradates for the 2021 data set. So we, of course, wanted to do the same thing, same comparisons drawn again for the 2023 work to make sure that we can provide enough evidence and support for the quantitative comparisons and the robustness of those comparisons for bifenthrin and fipronil classes, because those are very important and have been very important in the recent history of the program. So we can discuss.
Hey, Bushra, I just had a question on that last slide on the fipronil.
Mm-hmm.
So not having any detects in the targeted chemistry, is that a QA QC issue, or is that just a method detection limit issue?
It's a QA QC issue.
Okay.
It was just not the greatest set of data from a
Okay.
QA.
Thank you.
Mm-hmm. I will also say the concentrations from the fipronil concentrations here are fairly low. But but the fact that NTA, which has lower sensitivity usually, could still quantify these numbers, and the targeted did not presents a problem from a scientific point of view, but also from a financial point of view, right?
Yeah, but there's also a question of the QA QC surrounding the NTA on those. How valid are those? How accurate are those data? Right. So that's a whole another discussion.
Yeah, and like I said, so we have so Anna has assembled a QA QC document for the quantitative part of the product that I'm trying to describe, and the qualitative part as well. And we can like vet it and get it through approvals if need be to see if these data are robust enough to be used in the database. Okay. So did I answer your question, Jim? Is there anything else?
Yeah, thank you. That's great. Thank you.
So that's 2021. For 2023, where was I? So the same comparison, I'm going to talk about pyrethroids first. And we can discuss the limit of detections in a second, but the first column here is the sites, of course, and I'm showing 2 pyrethroids here. Bifenthrin is probably the most important and shows the most robust comparisons, and it's really important for SPoT from the point of toxicity, but also percent detections of how many places how many sites we detect, how often bifenthrin. So the LODs listed here are higher than some targeted labs. And for reference, the targeted RLs for pyrethroid in SPoT QAPP range from 0.25 nanograms to 4 nanograms for different pyrethroids. Bifenthrin in our QAPP is listed at 0.25. Here, bifenthrin is 0.5. So the question really is, are we comfortable losing the lower end of the concentration in the sediments? And 2, those lower numbers, when we get them from the targeted chemistry lab, are they consistent within the acceptable margin of error? So again, this will be a bigger discussion, but I would like to point out here that the comparisons from 2021 and 2023 for pyrethroids are very robust. And I've also highlighted, so all those blue cells show how close those comparisons are. And there are 2 sets of data that I have highlighted as red, which show that with one approach you had a non-detect or less than limit of quantitation, in the other approach you had a number, and they are not like in one direction. So in the case of bifenthrin and Tumbledero, you have no number for targeted and a number for from our NTA workflow. And these are good discussions and good points to bring up later as to if we get a number, we can go back and check, which we have done with Anna, and these numbers are valid. But overall, I would say that the numbers, the comparisons between these two sets of data are pretty robust for pyrethroids. And for fipronil, I would argue they're even better. The fipronil RLs are higher as listed in our QAPP, and the LODs listed here in the second column for each analyte are the LODs from Anna. So these are from our NTA workflow, and those are pretty good. And we are able to find very comparative data from both of these approaches. So can we start building trends using these numbers? I'm going to show you two examples which differ by an order of magnitude in bifenthrin concentration to provide evidence and support for the value and usability of these data. So this is Ballona Creek, region 4. The data listed here are for 3 different years, and I've highlighted the bifenthrin data in green. And in 2023, the numbers were very comparable. 21, there's a slight difference. And in 24, we did not analyze pyrethroids. So the only number we have is a non-targeted analysis quantitative end of that workflow. And I would argue that for years like 2024, when you don't have pyrethroid or fipronil or whatever data set you're looking, if you can get a number and the QA/QC checks out and it's approved, those numbers can be used to build some of the trends. So we don't have missing data. And if there is a need, those data that come out of the quantitative arm of the NTA work that we are currently doing, those can be tagged a certain way before they go into the database. But I think these are very useful data, and we have shown year after year that these data do compare really well with the targeted chemistry data that we get. The second example of a lower concentration, so the first, the Ballona Creek, forgot to mention, it's a very urban site. The second example is a site, if I pronounce it correctly and remember, it's Orostimba from region 5. It's an ag-dominated site, and the concentrations of bifenthrin are lower here, order of magnitude lower, and the comparisons are still very, very robust. In 2021, 23, there's a slight difference, but still same ballpark. And in 2024, we have no data again for this site or any site. We did not do pyrethroids in 2024, and the NTA data, that whole series of data for Ballona Creek and Orostimba, it shows that they are useful to draw trends. Okay. So that was just comparisons that I wanted to bring back to our NTA discussion, because we do need numbers to build those trends that are so important to SPoT. Another addition to the quant data is the list of standards that I had referred to in the beginning of the non-targeted discussion. And these lists include a lot of different kinds of contaminants. So we have BPA, we have antimicrobials, we have pharmaceutical and personal care products. I do not want to go into the concentrations here. What I'm trying to show is that you get additional layers of you can get additional layer of quantitative data using the set or the list of standards that we have right now. And the list of standards is rather large. So if we were to integrate this in a way that we get some quantitative data, then we can decide that for SPoT or for any regional work or anyone who wants to use this model, out of those 70, you can a la carte, like pick and choose 20, which are important to your question. You can get all the pyrethroid data, quantified all the fipronil, and maybe you want a set of pharmaceutical and personal care products. So there are different iterations of the combination of the standards that you can use from this list that we have assembled to add more quantitative data and value to the question that you're trying to answer. Again, this is continuation of the previous slides. We found fungicide, herbicides, quantified them, insecticides in some of these samples. In 2023, we followed the same model, but I have shown this in pie charts to explain a point about bifenthrin. So we used the same model in 2023, and I'm showing here as all the different things that we measured from the list of standards at percent contribution. A lot of these chemicals we do not measure for SPoT, and if we did, it would be a lot of money, and they may not be relevant. But the ones that are relevant, bifenthrin, they show up in the bright purple wedges, and then fipronil in the bright green wedges. So they do show up here, and we can get quantitations and build trends for these. Also, I do want to point out here that the contributions here are purely quantitative and mathematical. They do not reflect relative toxicity. They do not reflect relative importance to the questions that we are asking, but it does show the value of the quantitative arm of the product that NTA can produce for SPoT. Okay. So that's all about the NTA quant version. There is a qualitative end of that work as well, which is the list of chemicals that I referred to when I was describing two branches of the non-targeted analysis workflow. And in the next few slides, I want to go really quickly over what that would look like and how that can be useful to SPoT, and then we can also discuss if it is useful to SPoT, which I think it is, then how we can integrate that into a database so we can show that we have all these data for all the sites that we are conducting NTA at. So the current output includes, and I'll show you what these mean in the next few slides, a list of library meshed chemicals, which is basically you have a peak and you're going to in your NTA workflow, and you match it to different libraries, and you'll get a list of what those chemicals are. You also get PubChem stats. So that PubChem stats basically just mean that you get information on that chemical. So if your list of library meshed chemical that is bifenthrin, because your peak matches to bifenthrin, your PubChem stats would be pyrethroid pesticide. So it just gives you information on the chemical. So bifenthrin is a very easy example, but as you'll see, it can give you a lot more than that. It can tell you if it's acutely toxic. So all the information that you can get for the list of chemicals is pertinent if you want to do investigative work. The third thing it provides you is our peak heights. So that basically shows you how big is your signal, your relative abundance for that particular chemical. The last three things highlighted here in gray are part of the correlation. So again, I don't want to go in too much detail here, but what that gives you is ranked peaks, and the ranked peaks basically show you in your sample set which sites you are getting for a particular chemical. Let's say bifenthrin has a really high peak for bifenthrin. So it tells you that, and if that site is also toxic, that correlation may show you that bifenthrin is likely the driver of toxicity. So the ranked peaks, it's something that is important for the correlation model, and I can explain and we can talk more about how that is useful. But what is the most useful from the correlation is number 6 that's listed here, because the sheet gives you significant correlations at whatever scale you want. So you can pull out from this qualitative data sheet only the chemicals which are significantly related to a marker, for example, high level toxicity. And that is your narrowed down, pared down list of chemicals that you should be thinking about for that site or for the program or for that region. And then you can look if bifenthrin is showing up, if fipronil is showing up, and some other things might show up, which could be novel drivers of toxicity. So just to give you a scale of what these data look like in terms of number. So for 2023 data set, we had 754 library matches, out of which there was relevant information from the PubChem database for 137. So we've already pared it down. And you can run different correlations. And for every correlation, you're getting smaller and smaller set of chemicals or list of chemicals. And you can take any of those lists and answer very specific, or start answering very specific questions. So we did this using urban land use, which is important to SPoT's management question. We also did it using toxicity markers, which I'm going to show the orange and the pink examples. The yellow one is for CEC project, but that is also something that you could do. You can just add more markers to get different list of chemicals that we should be looking at as a program. So the first example here is example of toxicity correlation. There is going to be in a click in a second from now, a lot of data on your screen, but I just want to show what that looks like and I'll walk you through it. So this is a list of chemicals in the red on the first column, which are related to high level survival from our 2023 data set. On the right, you have the PubChem stats, which are information on that chemical. So all on the right, all the greens that you see, those are chemicals, either they're natural products or there's not a lot of information on that. So you can ignore that if you want. And you can just focus on those bright yellows. So that is the list that you have for high level survival. So it was negatively related to 34, relevant info on 5 available. And the right at the top, you see bifenthrin there, which again, it's a validation that in 2023, we had 18 samples. Just using 18 samples, we could gather the information that the program has gathered over a long period of time, over and over and over again. Not going to go into chironomous, but you can do this iteration with high-level growth. You can do this with chironomous survival, chironomous growth, and get list of chemicals, and then compare them to see what should be your priority chemicals. The second example of this qualitative list is in the context of urban land use. So you can draw a list of features which are related to, these are all significant correlations of urban land use, and look at chemicals which are related to different kind of land uses. So you can do agriculture and urban. So if you look at the urban land use table at the very top, you have pyrethroids, you have plasticizers, you have PAHs. So when I was showing you the PAH data set that I'll come back to PAHs, this is what I meant. So we are seeing some pH correlations, and for specific sites that may be important. Or again, reminding correlation is not causation, but that means that you can buy a standard, measure that pH, and see if it's exceeding any thresholds. But these are the kinds of useful pieces of qualitative information that can inform your quantitative steps for the program. Urban land use related to 290 features, 54 are shown here, and ag related to 28. So all the diversity of chemical footprint of the sediment samples in urban areas that I have been talking about is shown here as a list. Okay. Finally, the last example of what kind of qualitative information can be pulled from this is site-specific. So I'm going to use Ballona again as an example. So let's say you want to find more information on Ballona Creek. You pull all your high-level toxicity-related features, which I've shown 2 slides ago, and you grab all the peak heights, which is the last column on this table. And I have assorted them based on from highest to lowest peak height. And you can start looking at those bright yellow rows to see, are there important chemicals that I should be looking at? And of course, it shows bifenthrin there. And bifenthrin, this is the set of data where there was a really robust match between the quantitative comparison from NTA of bifenthrin and the targeted chemistry. So you can look at very site-specific questions and site-specific list of chemicals. And these are the kinds of data. These lists are, the way they are generated is not complicated, but it's tedious. But once the lists are there, these lists can be put in some kind of database to provide more information on sites and regions and statewide chemicals that should be considered in the monitoring program. So I'm going to give you a break from all those bright yellows to wrap this up and the NTA section of this presentation, and help us think about how these 2 branches of the NTA work can be integrated into our current design and how it adds value in answering management questions. So the management questions here are listed on the very top, and very broadly, we have 4 management questions. The first one is about trends of toxicity and contaminants at individual sites and related to land use. And the second one is effects on beneficial uses. The third is causes of toxicity and origins of contaminant thresholds. And the last one is the seeing the effects of regulatory actions. So based on everything that I've shown with our NTA workflow and these comparisons that we have drawn, NTA can definitely inform the first question, which is the trends. So we can obtain quantitative results for selected chemicals to maintain trends in years when commercial lab work is not planned. We can identify land-use relationship, as I just showed in the qualitative table with features, and we can investigate the trends that are useful. We can bystanders and measure certain chemicals, which may not be on our contaminant list right now because we just don't know they are important. So the first management question can definitely benefit from integration of non-target analyses. The other one that it can really benefit is causes, because the whole prioritization model is based on finding drivers of toxicity. So the whole NTA prioritization model is based on finding novel drivers of toxicity. So we can analyze the correlations that I have shared in the previous few slides to identify what are the current toxicity drivers, which may be on our list of targeted chemistry, and some may be novel, and then we can investigate those trends further. The other two management questions, the impacts on beneficial uses and the effectiveness of regulatory actions, can also benefit from non-targeted workflow if paired correctly and strategically with targeted work. And so when we use the correlations and the quant data that I have shared with you to revise the targeted chemistry list, we can keep in mind if we are seeing trends change, then the temporal and spatial scales of the targeted chemical monitoring can be adjusted. And if by using NTA, if we see novel drivers of toxicity, if we see new correlations pop up on a temporal scale, we can purchase standards and quantify that. And the extracts of NTA, once you extracted them, they can be stored, archived, and if you see some correlations, you want to go back and measure something and purchase a standard, that is also possible. So it definitely can augment what we are doing to answer our management question. So at this point, I think we are ready in a couple of minutes for a break, but before everyone goes for a break, I would like to leave you with this very insightful article that came out fairly recently. It's by Mark Striner, who is at RTP in the Office of Research and Development at the EPA. And he wrote this piece to show that there are definitely checks and balances and QA considerations that need to go into integration of non-targeted analyses into current monitoring. But there is a shift in environmental monitoring, and the integration of NTA should happen sooner than later. And so with all the data that I have shown today, when we come back from break, I hope we can have a conversation about what is the best way of integrating it for our program and what components need more work so that we are making the right targeted chemistry decisions and moving the program in a way that can adequately address all of our management questions. I think I'll stop here. I'm going to answer a few questions if people have. I think we have 5 minutes before our break.
Bushra, I've got one kind of really burning question.
Mm-hmm.
I'm wondering how similar the sample preparation methods are between the targeted analysis and the NTA, because that's just crucial. So the more they differ, the less likely it is that you're going to be able to have consistency and to be able to do trends. It always worries me when you're changing labs and trying to do trends. That's something that is really not best practice. So that worries me. A key part of that changing labs is having exactly the same consistent method every time, including everything you do with the handling the sample. So can you talk about that, or is that something Anna could talk about?
Anna can probably talk more about it. There are different extracts that are prepared, but I'll let Anna answer that in more intelligently, I should say. I know a little bit of it and how she prepares it, but she'd be able to explain it better.
Absolutely.
Anna.
Yes. The short answer to your question is I would need to do a one-to-one comparison of the lab, but I know that we've also done water sample extracts for Bushra's lab. We use the same basic methodology, which is for water, we use a solid phase extraction cartridge, which is a hydrophilic lipophilic balance cartridge. And then for sediments, we use a organic extraction. The exact ratio of our choice of organic versus the lab's choice of organic, that I cannot speak to. But I am fairly certain that we are using the same like scheme of extraction. But yeah, specifics I'd have to look into more.
Yeah. So thank you for sharing that. Just the idea that you're trying to use the same kind of workflow that the commercial lab would use is interesting. And that's just something I think would need to be thought a little bit more about. Thanks.
Absolutely.
Yeah. And Kelly, if I can just add something to that. So I showed pyrethroids and fipronil as examples because those are two contaminants that we have measured more regularly in the recent history of the program. And Anna and I have had like countless discussions about this, that, there may be certain chemical or certain analytes that are not suited for this model, right? There may be certain that you just have to go get targeted because of recover all the things, right? But knowing which analytes fall into that space help us block out money, which we'll talk about it after the break, and say, okay, these we are not going to touch with NTA. Let's just get targeted numbers. But that opens up the conversation of what we could use the NTA quant workflow and say, okay, we have enough confidence in these data to start building trends.
Cool.
Yeah.
Thanks.
Of course. And
yeah, I unfortunately have to leave at 10:30. So I was just gonna put a quick comment now. That was so interesting. I'm from DTSC with the Safer Consumer Products Program. And so as you were listing those chemicals, I was just rapidly screening, not the ones you were highlighting, but all the other ones, because we see those so much in our work and all the products that we're screening daily and the alternatives. So we're seeing the new chemicals that are being phased in as people are highlighting concerns about the chemicals that are being phased out. So would love to see if we could partner with y'all to help kind of, both I want the data to see, it can help inform our work to understand as we're studying things, oh shoot, they're starting to pop up in the environment. That could help us inform what we're doing, but also what we know to help inform your prioritization and your work, because we have studied some of these chemicals. So that would be really great. And then just my other thought, like I said, because I'll miss the discussion more, is just the value of doing the true NTA aspect of it every year. It's like how much is truly changing versus the targeted piece. And it sounds like you're not using a true NTA for the full non-targeted aspect of it. Every single year, you're kind of getting the targeted piece out of it. So maybe those can't be completely disentangled, but the true non-targeted where you're really looking for all the new things, in terms of is it needed every year, versus a more targeted.
yeah, that's great. Thank you. I have from my notes from last year that we need to have more conversations and communication both ways with DTSC, and
Yes.
I will work on that a little more at my end. Try to create more hours in a day, maybe.
Yeah, no, well, I mean, like, so we've got staff that love just running through data, and we've got access to databases and things that we can try and learn more about what those chemicals are.
I'd love to follow up with you and talk
Fantastic.
more about what, because I just showed snapshots because NTA has so
Yeah.
much.
Yeah.
And
No, and
yeah,
that's the thing,
happy to hear.
and that's why part of me was like, can I get those data sets? Because there's so much in there. So really
Yeah,
fascinating
we
work.
can do that. Yeah.
Cool. Thanks.
Thanks, Anne.
Yeah, thanks.
I'd like to provide a little bit of input as well. We're currently sampling drinking water wells across the state at disadvantaged communities. We're also performing non-target analysis as well, Bushra. And some of those lists of chemicals that you had listed, we are also seeing in drinking water. And so there is overlap as well there. We're sampling about 3,800 wells right now. We're halfway through. A subset of those are getting ultra shorts, actually PFAS ultra shorts. Method 530, the subset will be ultra shorts and non-target analysis. So we're going to have about 600 wells that'll have non-target analysis. So we're doing that at a commercial lab, the state commercial lab. So anyway, I think there could be some synergy here. We're not ready. We're still, all that data is still coming in and is very overwhelming, as you had sort of mentioned. And we're doing it here, just a few of us. So we're really relying a lot on the commercial lab. So anyway, something else to throw into the pot in regards to the NTA quagmire that exists, especially for PFAS. And, we're seeing a lot of we're seeing some fluorinated, but most of it's all non-fluorinated.
Well, that's interesting. We have talked about anti-PFAS for a collaboration extensively, and this is a great piece for that conversation. But yeah, we can follow up on that.
Okay.
Thanks.
Thank
Thanks, Wendy. Mary.
Thank you. And thank you so much for your research on this and sharing I don't want to call it preliminary, but the first few years of data that we have. As others have said, this is super important and informative and useful in a lot of ways. But I'm really curious about, and when we get back from break, perhaps we'll have time, but I'd like to hear more about a couple of things. SWAMP that funds this program is at its core about beneficial use impacts, right? And to evaluate that, we can evaluate in a lot of ways, but to use that to put something on like a 303D list and have requirements of ourselves to do something about it, put it in permits, we need a criteria for that evaluation. And we need a concentration that is backed by some known quality assurance evaluations, right? So I want to keep that in mind. And I want to also hear about how this is progressing towards that, supporting criteria development or the QC that will allow us to use this information as a concentration that we can compare to a criteria to evaluate beneficial uses. I'm all for the research and the development and the evaluation, but I do want to remind that this program is SWAMP funded, and that is a core element that we need to make sure we're careful with so that we can maintain our funding here. And then the other piece I wanted to flag for maybe later, more detailed discussion is some details about the QC and how I'd love to get in the weeds about that, and maybe not here, maybe in a side conversation, but the specific things that we're looking at or thinking about looking at to define the accuracy and verify repeatability of these things, precision accuracy. So looking at that a little more, and then I'd love to revisit the Ballona Creek concentrations slide at some point and hear from you about what other stuff you learned from that. You talked about bifenthrin and that it validates, that bifenthrin is a problem. We know that, but what new information did we learn from that non-targeted analysis about Ballona Creek? I'm sure there's a million things because that place is full of it.
Yeah,
I'll leave it right there. I'm sure we'll have more time for all the things.
and I just had similar comments to Mary and Kelly's. I think we all know that commercial labs live in a completely different QC space, maybe than research labs like Tom's. I think we just want to have a fuller discussion of all the details surrounding the laboratory QC to make sure these data are comparable for sure.
Yeah,
we are trying. We have been trying, and we have, like I said, assembled these very specific criteria, and we just need to have like a big discussion on: do they need to change? Do we need to add anything? And are they as robust as the targeted methods that a commercial lab would be using? I would argue that for a lot of trends that we have identified over the years, there is so much like this is not an argument not to use a chemistry lab, but I'm going to be careful here when I say this, but there are so many data which just don't we don't use it for our trends because they lack the robustness. And then there is change of the commercial app. So I'm not saying that we should not talk about the QA/QC for the NT. We absolutely should. It needs to be vetted and approved. But I think the way I look at it is I want to know what can we do to make the quant work that's coming out of this workflow more robust as we need to, develop criteria. And the comparisons with the commercial labs are only to show that this works. But I think my lens is if we can make sure that this is very tight and we can use year after year, then we can decide where to put the commercial, like the targeted chemistry money to. So I think this is a larger discussion, but we'll come to that. We constantly think about that, even though we are, like Tom's lab is an academic lab, and it's not an accredited lab, but we have, every time we do an NTA project, I'm constantly talking to Anna about the QA/QC that need to be documented and provided with the data to support the value of these data. And we can talk about that I thought I was doing good on time, but we're 6 minutes over. We can come back
It's
and talk
us,
about
it's not you, it's us.
It's good. Okay, Tessa, good to take a break?
Yes, let's take a break and
Okay.
we'll be back in
10 minutes?
10. Yeah, okay.
10 minutes. Sounds good. Thanks.
Ready to get started again, Bushra?
Yes. Here, I'm just responding to question to Kelly, sorry. Okay. You can still see my screen, right?
Yes. Yeah.
Okay. Okay. Let's talk money and plans. Okay, so I have so you guys have seen some version of this table in the past meetings. So just to quickly run everyone through it, we have all the years at the top. The yellow highlighted column is this current year. In the first column, we have the analytes, which are currently or historically been analyzed for the program. And then I have some prices. The prices that I have included in the first column below the analytes are the current prices, and some, like for metals, for example, the 306 you see for the suite of 5 metals, that was that has changed. So the new one is 700. But other than that, I've mostly used new prices, except for OCs and PCBs, because we haven't done that in 2024, so we don't know what the new prices are, but they're higher. All prices are going up, as we know. For NTA, I've used the older price, which was 3,000, and the new one, which is 3,530. And for this year, I have used for in the column which is highlighted yellow below the number of sites. So what you see, the 42 everywhere where you see, those are the number of sites that we had or we are planning on visiting in current year or in the future years. And below that is the number for that analyte in that row. I've also left some of my notes, recommendations, things that I want to discuss for each of these analytes in terms of the temporal scale, like the frequency of these analyses, but also the spatial scale of how many sites do we want to go to and what should constitute those 40. So 42 is including QA, QC, but 40 sites, what those 40 sites should be. So we can start with questions. We can give everyone a minute to digest this. I did not include that in my data slide PDF that I sent out. And some of these discussions go back to our last meeting where we decided to put OCs and PCBs for longer time scale. And I think it was Rob's recommendation that we look at hotspots. So that's why in the OC PCB row for 2028, that monitoring season, I have 10 samples. So if nobody has any burning question, I'll start with party points. So we are going to 40 sites. Go ahead.
Yeah, maybe I should have asked this earlier. I'm wondering if you guys have ever, and maybe you already did this, figured out if there's wastewater contributions to upstream of any of your sites. And the reason I ask this question is really important for fipronil in particular, and probably to a much lesser extent for pyrethroids. There's pretty strong data, particularly coming out of Europe, that are linking PET treatments, PET flea treatments, to actually meaningful concentrations of fipronil in surface water. So showing they don't have any of the structural pest control treatments that we have here in California. And there are studies on dogs just swimming in the water as well as sewage treatment plants, and pretty meaningful concentrations coming out. And they're really, the body of evidence is suggesting to me that what's going on with fipronil is more, the in surface water is more than just the structural pest control runoff that we'd seen in the past. And that puts a different color on what I'm thinking about in terms of your program. And that means the sewage treatment plants are one discharge source for it, and for the fiprils. And then the other is whether there's a lot of swimming activity up in the upstream watersheds. And I was really surprised by the stuff that's coming out, but seems to be properly done, and that's why I'm kind of rethinking what we're doing on fipronil.
So in terms of those relationships, I mean, in my time here, I haven't done that. I don't recall having done those analyses in a way, in like the programmatic way, but maybe Bren can chime in on this one. I haven't done that with fipronil recently. Kelly.
We
Go ahead.
looked back at sewage treatment plant inputs over the years. We've done that sort of sporadically and site specifically. We did it back when DeWitt Tedesse was doing his the bioaccumulation stuff. We looked at sewage treatment plant inputs, and there's no trend. It's pretty inconsequential. I think you could look at it as a site by site basis. But we haven't really wrapped it into any kind of meaningful direct analysis.
Bren, what year was that ballpark?
I can never remember. You know, I remember in increments of 5 years. So it's between 5 and 10 years ago that we worked with DeWitt on that. And we did that specifically because we put those passive samplers out for him. And I never saw the data set from that work. But we put the passive samplers out, and we targeted sites that had sewage treatment plant inputs. But you look at something like Los Angeles River, and there's a lot of possibilities there within that whole watershed. So it's dependent on like is it proximate in terms of just like linear distance in terms of stream length, or is it a question of how many treatment plants are in the watershed that might be contributing? Is it a relationship between the total flow of all of those treatment plants compared to the total discharge of the river? And we've just never dug into those data deep enough. We've had some issues with our fipronil data sets just for the last couple of years, just as it is. And so, maybe as we start getting fipronil numbers from Axis, through Babcock's lab, we're having Axis analyze our fipronil. So hopefully that'll give us some stronger data, and maybe we can dig a little deeper into that moving forward.
Yeah, I keep thinking about this might also be the explanation for why we don't see the land use correlation that we would expect with urban areas, is the sewage treatment plant and swimming of treated pets. So it's
a classic 3-dog night.
Yeah.
They used to have that problem with it was like diazinon or chlorpyrifos. The sewage treatment plants would be out of compliance if people had washed their dogs the night before.
Yeah.
I'll just mention that the kind of analysis that you're talking about is something that we've done at USGS for a number of different projects, looking at watershed scale contributions from wastewater treatment plants, et cetera, all these different variables. And it's pretty easy to do within a GIS environment. It's just having somebody to do that work, and it's not particularly complicated, but it is very useful. And Kelly, I'll just anecdotally, some of our data that we've seen, I've seen the swimming issue as well with the fipronil, and some sites that had no urban input whatsoever, but had either had recreational uses, dogs swimming in ponds, et cetera, or some of the duck clubs where there's a lot of hunting going on at that particular time of year, where there's a lot of dogs out in the water retrieving ducks. We've seen fipronil pop up, and why is that showing up? We know it's there. We got a good QC on it, and it didn't make any sense until, without that explanation, that was one of the possibles. So,
interesting. And I don't want to put Rob on the spot, but I think DPR has done some fairly detailed mapping, so it may be possible to get some access to some things that they've worked on. So thanks. I wanted to leap in with that because I think it affects the decision making on the fipronil part.
And to add to Brent's point, I should have mentioned it. So all the sediment analysis in for this year's monitoring as SJS excess numbers, because we have had issues and with the quality of the other labs, and we, for the 90 sites for pyrethroid, closed the loop on that story, which is the manuscript, and decided to do tier 2. But we are at a point, I think we are at a point that we can put pyrethroids on either the sites which are showing up and down. We can put them on a scale, on a larger temporal scale. We can go back to our NTA comparisons. There are many ways to do this, to use the chemistry money most strategically. And that's the bigger discussion, and I want to have and get inputs on that. So fipronil is part of that discussion, of course, Kelly. I mean, except PFAS. So PFAS, we're going to continue doing tier 2. I would say if we can build some space and money for some of the ag sites for PFAS, that is probably for the better. Because there's plenty of evidence showing that PFAS could be at those sites that are getting ag input, but we don't have to do a whole suite. We should stick to draw trends and relationships for these 40 sites for PFAS, because we're just 2 years in, 2 years of good data in, but we should throw in some ag sites. And if they don't show much, then we can remove them, but completely ignoring ag is not the way to go for PFAS, as most of you know on this call. Yeah.
We actually did a pilot study last year looking at targeting specific ag sites for PFAS monitoring. And there's a paper should be coming out. I'm not sure what the timeline is now, given all the things that are going on. We targeted sites that had specifically heavy use of methoxyphenazide, which is an insecticide that is one that can be a PFAS, depending on how you define a PFAS. So there's that whole issue too, right? There's a lot of things that might be PFAS, might not be PFAS. So.
There was a really sensational paper, I should have pulled it, about like fipronil and other pesticides and PFAS and what category some of these pesticides, right? You know, Kelly, what I'm talking about. Yeah. And then there are other things about what could be in pesticide formulations, which is where the PFAS could come from some of these areas. Anyway, we can talk about
we've been looking, since we're talking about this, I'll jump in. So we've been looking at trying to understand PFAS sources. And one thing I have run into in multiple forms is that in addition to the container treatments, which lead to a weird variety of PFAS showing up, not just in pesticides, but in all kinds of things, consumer products as well, that you and I buy, that are holding our various things to keep them from leaking. So that's kind of a bigger problem than just pesticides. In the agricultural areas, there's been some shift. So on some crops, people have been using plastic for weed control. So particularly for in the crops down in your area and so forth. So strawberries and other things. And there's been a shift away from plastic and towards paper type coatings instead, and those contain a PFAS in them. And so I've had a lot of people talk to me about the fact that I'm working on a big project on PFAS that's got an urban scope and excludes agricultural areas. And they're really concerned that we're not monitoring agricultural areas and that there's so little data about there because there's so few folks who really understand that those uses are occurring. So I just want to highlight that as something other than that. I know there's a whole argument about the definition of PFAS and pesticide and whether it's in or out, NDPR, and I don't want to weigh in on that, but I will say that there are other kinds of more traditional PFAS may also be occurring in certain agricultural regions, and it's something that we should consider as a state.
Kelly, just very quickly on that. So I've been working to develop, this is not SPoT related, but it would leverage SPoT to get some extramural funding with a assistant professor on campus at UCD, and we have talked extensively about the use of paper mulch and plastic, and so we're trying to get some USDA money, which we'll see how that would be working. We have like some blurbs written on what that would look like in terms of leveraging SPoT, but getting that piece of the PFAS answer. So yeah, I'm on it.
Awesome. On that note, Bushra, I wanted to bring up two things. One regarding PFAS, since we're here. I noticed that you have the question mark for 28, 29, and I wanted to lend my support for considering after we get enough data, several years to start talking about trends, that we reduce the frequency of monitoring for that.
Are we talking about PFAS, Mary? Sorry, I
Yeah,
missed the
PFAS. And then you just mentioned, finding additional funding elsewhere. And I think that for some of the parameters in this program, we're trying to support all kinds of areas of the water board, right? And SPoT is a swamp program with that core goal, or whatever we want to call it, objective to evaluate beneficial use impairment, and criteria is key to that. PFAS, we have some drinking water ones, but we don't have aquatic life ones yet. So the value of it is greater than just swamp's intended purpose. And I think that for PFAS, for the NTA things, maybe for some other parameters, we could all be really helpful in trying to find other funding. Like I know, water board departments, we have discretionary funds. It's small, but if NTAs is, less than 30 grand a year, a small piece of somebody else's discretionary funds could support that for a year and leverage work that SPoT's doing. Or, DTSC and other agencies around us that are involved, they might be able to cobble together something too to support swamp. So I want to encourage, maybe this is a Tessa question too, but I just want to encourage looking elsewhere to bring in funds for swamp. I know that's easier said than done, but we are building data sets here and answering questions that support multiple water board groups, multiple agencies, and so we should ask them to jump in.
Yeah, I can respond a little bit to that. So we definitely are looking for all kinds of funding sources. One example is we have this collaboration with the CEC program. So
Yeah.
we actually have
Huge.
leveraged a lot of funding with them. They've
Mhm.
gotten 205J funding, they've gotten discretionary funding. So, we're kind of doing the same and trying to continue working with that and looking for all of our opportunities. But as everybody's budgets have been cut around the state. So it's sort of, we're looking as much as we can and asking for what we can, but there's a lot of people who don't have much to give at this
No, I
point.
totally get it. Neither do we, right?
Yeah, right.
We're all the same. Tessa, I am interested in that 205J funding because as a regional representative, I wouldn't hesitate to go after 205J funds for, leveraging more work in my region too. Is that,
Yeah.
Can you point me to that or point me to who is managing that grant in the
Mhm.
CC group? Awesome.
Well, really, it's Rebecca Fitzgerald
Okay.
is the lead of that grant, and then it's been
Perfect.
Erica working, trying to get funding for a CEC program, but she's switching or has switched positions. But I know we have Manuela on the line too, and I think
Okay, I'll contact them offline, but
yeah,
maybe we can bring more in that way too.
I mean, and that, to Mary's point, I mean, the funding that we have from CEC, that has really helped us keep pushing the NTA workflow and the product forward. I mean, their goal is slightly different, but like I said in one of my introductory slides, it's really positioned us to look at it from the SPoT lens. And so the data that we have generated beyond the pilot is all CEC and Region 1 funded. And for this year, it shows at the bottom of the yellow column, we have 12 sites. And initially we were hoping to do more sites. So those 6 sites, so initially we were hoping to do 18 sites for NTA, and we only decided to do 12 for the collaboration. So it would be nice to have the continuity and do those 6 samples using SPoT money if we, so it is important to find, more funding to continue using this so that we can build a product, show what we are doing.
Yeah,
with
but
it.
sure, it'd be helpful to push out to the regional board coordinators. I see Chad's hand up, for example, like a cost amount that it would take to do 4 sites, 6 sites for NTA in our region. Because if the discretionary funds are still available when the time comes to do something with them, that's something we'd be very interested in. So that costing of that out would be useful to me, I'm sure to others too.
Chad, thanks, Mary.
Yeah, I think I just wanted to pipe in because we're really interested in NTA specifically for doing like stream bioassessment, causal assessment work. I think that's
Yes.
a big area that we'd like to expand NTA work into. So I guess the question for you and Tessa right now is the NTA included in the new UC Davis statewide? Okay.
Yes, it is.
Okay. And is the cost is the 3530 for that?
That's correct.
Okay. So hopefully I can put some discretionary funds if those keep coming in towards that. That's something we
Okay.
would like to do. Thank you.
And one thing about NTA, which is probably obvious the way I showed this slide, so it creates a lot of data, and then there's a lot of time that is spent sitting with those data and getting out what you need from it, because you can scale it at many different ways, right? So it does need, beyond the sample extraction and analysis, processing of the data, which is the sheet we would get from Tom's lab. After that, whatever question we are trying to answer, it needs time, someone with enough experience to sit and draw basically what I showed. So that just adds a little bit of time, but I think it's worth the money to do that. I'm curious in this group if anyone is using non-targeted analysis from a commercial laboratory.
Well, Wendy Link talked about that. They are for their PFAS and drinking water
Oh, for PFAS.
wells. They're using Babcock.
Babcock.
Yeah.
But nobody is doing any other matrix than drinking water for NTA, PFAS NTA or NTA in general from the commercial lab space.
No, we work solely with academic partners. We're doing a lot of NTA.
Yeah.
And Tom's lab is awesome.
Yeah, it's amazing. Yeah. No, I'm not asking so that I can find something else. I'm just curious what kind of products they are producing, what kinds of QA QC is in play, so that we have assembled, and by we I mean Anna has assembled this long document with a lot of information for both of those arms that of the NTA workflow. And we can discuss that, but I just want to see in the commercial space, people who are doing NTA, what kind of QA/QC measures are they expected to present? Yeah, Tom's lab is amazing. I mean, it's been a wonderful collaboration, and the CC collaboration is phenomenal because there's so much we have done with this and worked through different kinds of relationships for these trends, for these chemicals. So it's really good to sit with these data and figure out how, because what it has allowed us to do in the last 4 years is think really hard how we can make it like a core component. And I think that discussion is very important. So I'm going to go back to the pyrethroid. So we are going to 40 sites this year, and if we put pyrethroid, so we have already put pyrethroids on every other year. So we didn't go to pyrethroid, didn't do pyrethroid analysis in 2024. We had a data set from 2023, and so we are going to 40 sites this year. If we put pyrethroids on a 2 to 3 year cycle, or select of say 10 to do every year or every other year, based on the data, based on the story that has already been told for pyrethroids, how does it fit within what is important to DPR, what is important for the pyrethroid TMDL work? Are we comfortable putting it on a 3-year cycle? Is my question.
I'm comfortable putting all of these relatively persistent ones on some sort of cycle once we have baseline data. And then being strategic about, this year we bring in these two and those two are not being done, and then sort of trying to balance it out that way. And everything on this list except fipronil seems to be something that is going to be relatively stable unless there's something new happening.
There.
Kelly?
Yeah, I've got a bunch of thoughts. The first one is I think it really depends on what DPR's needs are and anticipated plans, I think are really important. And given that Rob's not well today, maybe that's a follow-up conversation. On pyrethroids, I'm kind of inclined to support what Mary's saying and say maybe we don't need to do it so often because it's been now 13 years since they implemented the urban regulations, and we're just not seeing what we expected. And there's been very site-specific stuff when it comes on the agricultural side, so it's a little different. So that makes me wonder, is it worth the investment to be doing that this coming year? Fipronil feels different because there's some weirdness in the results there, and I would actually love to see more money devoted to data interpretation for both that and the NTA. So if, putting off pyrethroids helps provide some of that money, that would be my pleasure for sure, if you guys can switch between direct and indirect costs. As a general thing, I'm really concerned about the idea of using stuff from different labs to establish trends. So at the regional monitoring program for SFA, that has not worked well for us. So in fact, it's worked really poorly. We've had some big issues when we've just switched labs after using one lab for a long time. We thought we had trends on PCBs that we didn't have, and we spent years digging through that and digging it out. And so the idea that we'd go back and forth from not even different labs, but different methods, really concerns me. And I recognize that the lab changes have to do with the way the state board contracts labs. And I want to again say that's a really fundamental issue for this program that the state water board needs to figure out how to address. It would be better if there was a state lab again that could just do everything so that we could have everything. And without that, we have to find a way, because I don't think we can compare copper data from different labs in different years or any of these other data from different labs in different years and be confident that we actually know anything. So really, really concerned about that. And I know everyone knows the answer to this, but I really want to lay that out there. So I don't see the ability to use NTA to fill the gaps in any way in terms of trend analysis. And just to make that clear, if we were doing NTA every year, doing the same thing every year, I'd actually feel stronger about that. And NTA is starting to be pretty good, and I think your data are showing that. So when we met last year, I was more nervous about it, and I talked to colleagues here, and we're starting to feel more confident that a really capable lab like Tom's lab, if it kept doing it over the long term, we might be able to do some really cool stuff there and actually look at potentially doing some trends things for certain chemicals where we have the standards. But I would not think that we could switch labs. That would just be disastrous for NTA.
Right. Go ahead. Sorry, Kelly. Didn't mean to talk
Well,
over.
just wanted to, while we're here, I did want to say a couple of the things. I love the use of the management questions. I'm really glad that you guys established those. And I think those are really important when thinking about the decision making about this year's program and future years program, that really coming back, honing in on those management questions and what it is that the program needs to do to achieve those. Couple other things. I think copper and zinc are really important at tier 2 sites. And again, having the same lab is really important for that. I really liked your visualizations. So that's totally not related to this discussion here. And I think that's a good example of how you guys can think about your data in lots of different ways. Having enough time and money for data analysis for this program is really important, even if that means some lower frequency of monitoring for the targeted analytes in particular. And finally, on PFAS, that is one place I differ from Mary, in that there are a lot of changes going on PFAS. So the market is really changing. The science is really changing. The targeted 40 list is not very good. I mean, it's good enough to give us a few things. The real science is going on with other methods. Wendy mentioned, looking at the ultra shorts, and there's actually the whole issue about the really, really like TFAA accumulating in the environment. And that could be one of the biggest environmental crises coming up in the next decade, that we're getting all of these things. So they're coming from fluorinated gases too, so not just from our fluorinated products. In our work, we're learning a lot about replacements, products. So some of especially the side chain fluoropolymers, our advisors keep calling those to our attention, that degrade. And so we're trying to actually try to work through what the pathways are. Basically, new products aren't getting rid of these things. We are getting other kinds of fluorinated chemicals, and they all eventually degrade to the TFA, PFAS, PFOA family of, the acids and the sulfonates. But that's a really huge issue. So if we don't do the targeted 40 every year, I'm totally good with that. But I think that if the years we're not doing the targeted 40, or maybe we save our money and do some other methods. So whether non-targeted is part of that, I don't know. Just to say, I think that the PFAS area needs a lot more thought. It's really, really major for the state.
I would say for the PFAS, I mean, we just have 2 years of solid data for now. That list of 40, I mean, for the foreseeable future, it's there. We don't have trends. We don't. Yeah. So I think that we could add other analyses, which will just up the price for PFAS. But these 40 are important. I know the concern around the ultra shorts, are concerned about the alternatives. So these are just the legacy ones, but we don't even have for the program trends for the legacy ones, which we do need to create, I'd argue. So I mean, for now, in my spreadsheet, mental spreadsheet, PFAS are there using 1633, and we can talk about, as the trends emerge, do selected sites for additional analyses for PFAS. You can, we've talked about TOP before. There's no AOF for sediment, but that's come up for our water conversations for CC. So yes, so the PFAS are on that. For going back to your NTA point, Kelly, so the change in labs, I know it could be catastrophic for a lot of things, including NTA, but right now our plan is to continue with Tom, and Tom is not here, so I don't want to speak on his behalf, but I mean, I don't think he's retiring, but
he is taking a new grad student, so he's at least another couple of years.
So if we can put a 5-year time scale on the NTA work with Tom's lab, that gives us a chunk of data to run a trend analysis. And which is why I was talking about the commercial lab space for NTA, because I wanted to know if somebody's already using it. And with those trends, if we can say that the QA/QC is approved, whenever that shift happens, the NTA field and the work within the NTA space, I'm going to say that in 5 years will be at a different place as fast as it's moving and growing. So do you feel comfortable in taking the work from Tom's lab, making sure it happens in the next 5 years there, and start drawing some pieces of information and trends if we can confirm that we're not changing labs for NTA in the next 5 years?
Yeah, if you're not changing labs, that's the thing. If you're envisioning that eventually you change labs, that makes me really nervous. So that's just as an overall thing for a program that does trends, it really needs to have the same labs, same methods, all the same stuff. And we've had this conversation before, and I'm really sorry, I don't want to make the state water board people think I'm berating them, because I am not.
Just to reiterate that a little bit, it's not just keeping the same lab, but keeping the same methodology. And in a research lab situation, that's pretty fluid, especially with NTA, right? You're always trying to tweak things a little bit to make them better, right? But whereas a commercial lab is not necessarily going to do that because they're locked into a certain method, right? So that's something to think about for sure.
We can implement those measures in the academic space for our projects. I mean, that's a conversation that we have been having with Anna and Tom about, because they have done so much work with us since 2021 that the way they may have, and Anna, chime in if you think I'm misrepresenting, they may try to do something else with another set of data. But for these agreements, contractual agreements, we can put, this is my hope, that we can put those QC measures in place, and for them to show with every data set that those are being followed, just like a targeted accredited lab would, so that we don't lose the 5 years that I am hoping that we can get from NTA, and lose this big chunk of data and wait for it to go to a commercial lab space in another 5 years and just hope that the state chemistry contract for NTA would never move to another lab. I'm just uncomfortable missing the pieces of information that the program needs right now. But I completely am in agreement with the QA/QC measures and what they need to be and how they are reported. But I think we have done enough groundwork with Tom to establish this relationship. And I'm hoping until he retires, he'll continue that relationship. We have talked about cost. We've talked about who's going to do this when Anna graduates. Like, we have had those conversations in hopes of building these trends. So I'm really uncomfortable sitting for 5 years, hoping there would be this one magical NTA lab that the state would never break up with. Because I think what we have here is robust. But again, these are just my thoughts. But we can have that absolutely can have that QA/QC conversation.
And I can chime in on that. The major change I've made, because I've done all of the data analysis so far, is I've just been realizing QA/QC steps that were missing, and I keep adding them year after year. Like, how do you define the range of, for NTA, there's an alignment step where you match up all the peaks. How do you define that window year after year in a systematic way that isn't simply going, oh, this looks about right. Like, what values can I pull by integrating additional targeted analysis, by integrating additional chemicals, like how do we adjust our injection order to be more robust? That kind of thing is like the major, from my end, the major addition I've made over the years, in addition to just including more information about the chemicals I find, to try and build something that can be given to another person in my lab for them to repeat and not just have it all in my head. And hopefully that transfers to whenever Bushra switches labs, or there is a handoff somewhere, that there is integrated systems for QA/QC that will keep this consistency over the non-target analysis so that the data can be compared over the years.
And we designed our monitoring plan for this year, going to 65 sites, so that we can build time. Like, I can build more time in my day to focus on these products or visualizations or running these data and like the data interpretation that Kelly and Mary, both of you were talking about. And so that's built into the design that we have for this year.
I'm just going to interrupt for a moment. Tony, can you just check the waiting room? I think we've got a person or two waiting to return to this meeting. Can let them in. Or I don't know.
And
Sorry about that. I was taking notes. Yes, thank you for that.
And I saw Brent's hand raised, and then it was not. I'm sure there's something important we can learn from that hand raise.
It's not important. I think Kelly continued to talk, and I think she answered or made my point in that, we're very focused and have been very focused on trying to maintain data integrity, throughout our program. And since we switched over to the state lab process in 2018, we've been trying to work with the state contract lab to guide where our samples go. And I think the relationship we have with Babcock currently is good enough that we can work with them to get our samples to go to SGS Axis, whom we have confidence in currently to give us really, really high quality data. If their price is any reflection of that, then I think it's going to be good data. So we think that we have it sort of with the targeted part of the program. We kind of have that figured out, that as long as we can keep that SGS Axis relationship going through the state lab, or in any method, whether it's through the state lab or not through the state lab, if we can keep that relationship going, we feel good about our targeted trend data. And then, of course, Bushra just addressed the consistency we're trying to have with Tom's lab, with Anna being the current primary analyst, and having these methods in place to pass on to the next people that are going to be doing these analyses. And we're going to be very, very careful if we ever transfer our NTA work to a commercial lab, which personally, based on my experience, I would be very, very reluctant to do. We'll just cross those bridges when we come to them. But we want to establish these trends, and we want it to be very, very solid. And just to address a comment that Mary made a little bit earlier about having really, really high quality data so SPoT can address the beneficial uses part of our state board mandate. We're also very, very keen on that. We know that is the primary use of SPoT data right now. These integrated reports that come out, we know our data need to be very, very high quality, and we're looking at creating that kind of quality with the NTA workflow so that the state and regional boards can be confident in what we're producing with our program.
Just to chime in, this discussion is, of course, really important, but we are with about half hour left before meeting 10. I think we have one more agenda item to get to. It may not be a long one, but just to keep everyone a heads up on it.
Thanks, Tony. Okay.
Well, before we move on, can we talk about metals?
Yes. Yes, we can.
Can we do it quickly?
Yes. Do you want me to just do you want to ask a question? No.
Just curious. I'd like to hear more from others who'd like to see this monitored in a relatively frequent manner still, and maybe I can be educated, but I'm not. For my purposes, that data, we could spread it out a little further in between sampling events and still inform the work I'm doing. And I'm just wondering if others are feeling the need for at least an every other year frequency, or what are we doing here?
Kelly, you want to talk about copper?
Yeah, so there's in January 1st, 2025 was the year for that which new copper brake pads for new cars, all copper, right? So less than 0.5% copper. Replacement brake pads for older cars can still have more copper, although Washington State's laws make it more likely that most California brake pads are going to head towards copper free. So we're just seeing that change right now. And so we're hoping that's going to be response that is really important for protecting salmonids. So having information about whether the environmental response is actually occurring is important. And then there's zinc levels in tires that are associated as one of the big sources of zinc in at least Southern California and places where there's 303D listings and TMDLs. And I know DTSC is considering management action on zinc in tires. So again, having data on that would be useful. Now, whether it needs to be every couple of years, I'm not so sure because they haven't taken any management action, and that again would take a little while. The copper, I think right now is the big period of change. So we do have a good baseline data set. And having fairly frequent monitoring for copper would really help with that under it as quickly as possible, seeing the management response.
Yeah, I totally agree with that. But I feel like the more frequent monitoring should be happening in the watersheds. These being bottom of large watershed sites, of course, are going to get like the maximum, and the salmonids are jamming past that part of their creeks real quick and going to where they want to be. You know what I mean? And that's where we need the data, is where they're spending their time and where it's really impacting them.
That'd be awesome, but there is no statewide monitoring program. There is no other monitoring program that is collecting these data. I spent 20 years trying to get somebody else to do that. And so we have no other baseline data set. So at this point, this is the sole program in the state to evaluate the effect of the copper brake pad law. And I think—
Well, we are in my region, Kelly. I'll send you our data. We've got some.
Well, everybody has little bits and pieces of data. It's going to take a pretty large data set given the variability, especially if you've got stormwater data, to be able to see these changes. So I literally spent decades trying to do this, and it's really obvious. And so I don't know if anybody's still on from DTSC, but they actually did a report and recommended that the state establish some different monitoring programs. But I don't know what's happening there.
So what do you think about frequency, Kelly? Like every 3 years, every 4 years? Like what's a minimum you think? I mean, I know you'd like to see it everywhere all the time. I heard that.
Well, I'll let you guys think about the statistics on that. I think right now, because the changes happening, that every couple of years is probably a good idea. But Ann Cooper's just turned her camera on, and I know Jim has something to say, so I'll shut up.
Just a quick comment, and I don't know if it's relevant to this program or if the toxicity issue is a relevant one, I guess. But has anyone considered adding metals that are important in the lithium-ion battery production use arena, since seem to be having more frequent these large-scale fires like at Moss Landing? I know we got into our shop questions from the public and other folks. Who's monitoring for these metals in the environment after these events? I'm just wondering if that has been is on anybody's radar.
I don't know if anyone from Moss Landing is here. I know they are monitoring. They did a study, but let me put it this way. I haven't looked at the numbers. They're not, from what I have seen, they're not concentrations which are toxic to at least our models, but there is work going on the Moss Landing battery fire. And I would just coming back to the budget end of this, if you do two metals, single metal is 360 and a suite of 5 metals is 700 right now. So you add copper, you add zinc, you add lithium, whatever you are adding, it just keeps on adding up to that. So I think if metals are to be done, it just like this discussion has to be very strategic. What metals at what sites we may not require a broad brush of all tier 2 4D sites. Look at trends, look at they're not at toxic levels for at least our organism, and parse out these are the 10 sites we are going to go this year, and then the alternate years, and then do it strategically. I think that probably is the best way I think we can support all the address metal related questions. Okay, and
yeah, I was just gonna support what Kelly said, that on the copper, the ability to see some sort of trend, if there is one, as a result of the copper brake pad law would be great. And y'all know way more than I do about what's needed to be able to make some sort of statement around that. So yeah, that would be fantastic. And on zinc, we are still in the rulemaking phase and haven't yet noticed that rulemaking. So it'll be a few years out. And even with that, there's not a clear alternative for zinc necessarily that would even be immediately incorporated. So we can definitely keep y'all updated on that progress, but it's not like it would be, there's not anything immediate in terms of reductions in zinc concentrations in tires that we know about, unfortunately.
And this is really good, but I'm learning with every passing SRC that I'm a part of. We just need to have more of these conversations, more than once a year at SRC. So we are all, looking at things in the same lens. And so, once we start putting these things together and say, these are the sites, it'd be useful for SRC to take a look and say, do this, don't do this, things like that. So we need to hear more what's important for the agencies and for the regions. I'm going to jump to the next one because Tony already has reminded me we're at the near the end. So the next slide is the same, but for toxicity testing. And I'm just going to say real quick that we have cut down on the number of sites that we are visiting this year. So we do the 40 tier 2 sites every year that's core to the program. And then the other 50 out of the 90, we are now in a design on a model that we are visiting those every other year. So for every year, we are going to 65 sites doing the toxicity testing, and we are trying to create time, money, resources, bandwidth to do more data interpretation, create more of these visualizations, sit with the data, NTA and targeted in the context of land use so that we can better spend time creating products that address the management questions. I'll come to the products in the next slide. But does anyone have any quick thoughts on this plan of going to 65 sites? We discussed this last time when we were showing our monitoring design. And those 65 sites are for Hylala. Chironomus already is at 60 sites, out of which 40 are the core urban tier 2 sites, which will continue doing Chironomus testing. It still adds value, identifies unique sites, as I showed at the top of this presentation. And then the 10 are for Coronimus. 10 sites are on that every other year cycle. So we will sit with this model. This is the first year that we are going to 65 sites instead of 90. And this would be a good test of how much time and bandwidth do we create this year to create the things that would be useful as products and deliverables for the program. Okay, we already discussed most of these questions, but I sent these in my data deck, the data slide deck, and I think we have had good conversations about the targeted analysis, the frequency of that, the toxicity assessments, all the NTA work. I do want to talk about deliverables because that is something that we talked about. The need for having visualizations and deliverables was discussed in the last SRC. And so we have changed, like I said in the previous slide, the design, the way we are approaching the monitoring design is to create those bandwidths. So one thing that was brought up in this quarterly meeting was SPoT quarterly meeting with Tessa, Ali, and Tony, is that we could do a quarterly newsletter with everything that SPoT is doing, the sites you're going to. And that is something that we would need help from the water board so that we can design it in a way that is useful. The other thing, so I'm reading and referring to the last bullet point on this slide. And the second thing that we have talked about in the last SRC was annual, like fact sheets. We didn't say annual, but we say fact sheets. So now that we have some bandwidth in terms of having time, we are gearing up to make fact sheets for each analyze, some of which will have, all of which would have the maps that I showed as examples of pyrethroids. And then we will have some information and we'll design that for analytes which are currently being monitored, and we can close the loop on the analytes which are no longer being monitored, but have a robust data set. And then if there are summaries that the regions can benefit from, we can create it. I do realize for the deliverables, I don't want to overpromise and then say, oh, we don't have the bandwidth. So we need to hear from the regions if there is a specific kind of summary that they can benefit from, and we can start that conversation. I can reach out to the leads and say, see what we can produce. So all the GIS work that one of our team members is doing, and in conjunction with all the trends that I have showed, those can inform all of these deliverables. But I do want to ask what other kinds of, if people have ideas about how we can package these data into science communication and information pieces, because at our end, as academics, we are required to produce publications and presentation at conferences, but I am trying to right now convert some of those presentations, such as an academic poster at a scientific conference, into a simpler pared down version so that it can be used as a fact sheet or a summary. But if anyone has any thoughts or ideas, we can talk. Mary.
You are gonna get yourself overcommitted, but I love it. I'll just comment on a couple of these. Quarterly newsletter would be cool. I think that's overkill. You guys have better things to do. It's just my opinion. Fact sheets, a great idea. Another way to do it would be create a dashboard where you just upload data underneath it every year. So once you put the time in to create it, you don't have to redo it every time. It's automated a little bit. And that way there's a fact sheet that's updated every year that anybody can go to and zoom into their areas of interest. So that might be another way to do it. Regional summaries, we'll reach out to you on that idea. And then I just want to flag, I do want to go back to the toxicity stuff when we do finish talking about this. We went through that kind of fast. I missed my opportunity to jump in.
Also, real quick, so we put all of our data. So I update the Grand Canyon website every year. That's where all the updated trends are after every SRC. So that's an annual upload. This is where I want the GIS visualization and the fact sheet could go. But we do need a link or a connection to that website. That's just our website, the Grand Canyon, on the state website where SPoT is described. Otherwise, that information piece is like floating in the universe without the right kind of connection. So I don't know what we can do to make that connection. And it would be the SPoT website on the State Water Board's page, the SPoT page on the State Water Board website needs to be updated, and I mean, at the very least, we can have a link to our site that is annually updated or as needed. And then we can, I can just create that one tab on that website where we can do the fact sheets upload. But for it to reach the right audience and the people who need to see that, who may or may not read in my signature that there is a Granite Canyon website link, I think it needs to be on some sort of like state page for the program.
Yeah, we can definitely add links to the website. I thought we already do have a link, but we can work on that.
We'll update that, yeah.
But I mean, another idea is like we have the SWAMP dashboard that does have spot data. So it's like that might be another place to try and get some fact sheet sort of stuff linked or something. We can, but you know, same as you, Bushra, we've got bandwidth issues over here.
Yeah, this is not to say that.
I love all these ideas though.
I just want the data to, like, as you and I both, like, we all want the data to reach, to be packaged in a way that is informational and can reach the folks. And it takes a lot of time. Just updating the Granite Canyon website, it takes so much time. So I understand that there are like bandwidth challenges, but whatever we can do to make that data, you know, reach the right people and the agencies and partners, that'd be great. Kelly.
Just quickly on this topic, I would not underestimate the value of the conference presentations and especially the papers, because when agencies are taking regulatory action, they need a reliable, thing to put on and to describe. I also really differentiate data upload, it's available, and information where it's interpreted in relationship to the management questions. So I think it's really important for this program to think about what's reasonable and feasible in that regard. So the publications and that data analysis scientifically are important, and having information that pulls together the key messages in a managerial form for those audiences is important. And honestly, I can't describe that for you because I think that the management questions define what where we are on the management questions may need to be periodically assessed and reported in a manner that gets to decision makers across the water boards and other agencies. So just throwing that out there for you all to ponder a little bit, even if that means a little less chemistry lab work or something else. I think that's just crucial because data are not information without interpretation and explanation.
Along those same lines, it's just really, I think it's really important to understand who your targeted audience is. Is it the public? Is it managers? Is it regulators? And that's going to really define the products that you put out and how much time it takes to do those things.
Agreed. Yeah. Mary, can we come back to your toxicity question real quick?
Yeah.
I have
Whenever there's a good.
Yeah, we can do it now. If you can do it in like 5 minutes. I have another slide after this, but that would go really quick. But go ahead.
Well, the toxicity one was about the budget idea. When in your first part of the presentation earlier this morning, you were talking about reducing, so sites that are toxic all the time, reducing the frequency at those sites. And I was just wanting to check back in on that about what about the frequency at sites that are always not toxic? We have a lot of sites on that list that are not toxic. So something to consider would be a rotation between, so let's say we take, instead of doing every other year at sites that are toxic all the time, maybe do a year off at toxic sites. And then next year it's a year off at several non-toxic sites. And that way we reduce the number of times we aren't sampling at toxic sites, because those are really informative to us. And I feel like I'd rather see more frequent data at my toxic sites than at my non-toxic sites if I had to choose. But maybe there's a way to kind of rotate through them back and forth.
Yeah, so for the toxicity and of the budget, the very toxic sites, which have been consistently toxic, so those are mostly captured in our tier 2. But then there are some sites which show toxicity and then come back up and down. Those are not on tier 2, so those are on the alternate cycle. But similar to what I said about the targeted chemistry, there's a way to parse out what those 65 should be for every year. This is the first year we are doing it, so it made sense and it was safe to go with the 40 core and the 25 others. But every year when we do 65, we can put some on a longer cycle and then bring back the other one. And that also depends on previous year's data sometimes. Like there was one year when Bishop was very toxic and it has been not toxic in Region 6. So for next year, it would be meaningful to go back to that site to see if it's not a sustained toxicity. So yes, those are important conversations. This was the first model of going with 65 sites, but I agree for all analytes, targeted analytes, as well as NTA, as well as toxicity. I think the broad brush of do 40 tier 2 and then put everything else on a rotation. There are better ways to do that by looking at site-specific, region-specific trends and making sure that whatever that matrix is every year is informed by the needs of and the data from the previous year. 100% agree. Yeah.
Thank you for that additional detail. I forget about that.
Thanks, Mary. Okay, I think we are ready for the next. So this is the presentation of SPoT data in 2024-25. So we presented at the North America annual meeting in Texas in 2024. And we are, so we presented, so Anna presented a non-targeted prioritization talk, and I took the same data set, but presented it from more of a monitoring point of view and integration of NTA as a tool in that. So that was a really fun talk, very well received, and got a lot of inputs from the non-targeted community who was attending CTAC. PFAS has been also presented at CTAC last year, and we are hoping to have more products at CTAC this year, which is in Portland, so which I'll present in the next SRC. And then there is NorCal CTAC, some of the work that with the visualization that I showed, we have created some visualizations for copper. So Randy Barton, who is a staff research associate on this meeting, she will be presenting one of the poster on copper trends so far using some of the visualization. And then Anna is also presenting non-targeted work at NorCal CTAC, which is in 10 days, like soon in April. And then for manuscript, one is under review. That is our pyrethroid long-term data set. And the NTA work led by Anna, that is assembled. It is going through its last fine-tuning. I need to get back to Anna after reading it completely, and hopefully that be submitted soon. There are other things in pipeline, so we are working through it. So hopefully, again, it's a bandwidth thing. Academic papers take a long time to assemble. So we'll move through it and hoping that some of the trends that we have closed the loop on, and also like something like copper, we can put in monitoring journals and have these pieces out in the world. And then finally, we have the collaborations that we currently have. So we have our biggest collaboration is with the CEC program of the Division of Water Quality. I've shown a lot of data that is part of that program, part of that collaboration, and was funded by them. I've not shown the water side of this. So whenever we are working with the CEC group, we are going to the SPoT sites, collecting sediment as well as water. This year, there is more work that is added. We are doing a larger suite of bioanalytical receptor activity assay. We are adding AOF and 6-ppd quinone both to sediment and water for the 12 sites for year 2 of CEC. So that's going to add another layer of data. And then we do have another year's work with them, which is mostly computational, I would say. So no samples would be collected most likely, but there's a multi-program integration of non-targeted work and CEC monitoring tools. We also have, so this is under the larger umbrella of toxicology and contaminants program, of which SPoT is a part. So the first one, the CEC one that I just described is a SPoT leverage. Then we also have, separate from SPoT, collaboration with CDFW, Office of Spill Prevention and Response. So we are working with a renewable and conventional diesel toxicity project, where we are looking at renewable and conventional diesels, as well as different kind of blends with freshwater and marine organisms. So doing invertebrate, we're doing fish. A lot of work is currently going on, has kept us busy and during months where we are not doing SPoT sample analysis or toxicity testing. And then finally, we we have our continued collaboration with Morro Bay National Estuary Program. So we're doing sediment and water toxicity testing for them. Some of this work is currently on hold because they were federally funded, but we hope we'll be able to resume some of the work in the dry season. And with that, I think we are at 5 minutes from noon. Any closing remarks? I know, Mary, we didn't get to your Biona. I'll reach back out to you with
That's
the
fine.
list of
Yeah, I'll bug you later.
Biona and QA/QC. And as we assemble those documents, we'll share them with the SRC so people can look at it and provide inputs on the QA/QC documents that we are generating for the NTA workflow. But I'll stop here, and if there are any questions, comments, concerns, criticisms, all of them, we can address them in the last 5 minutes.
I just wanted to wrap up by saying that this continues to be an amazing program. It is really budget limited, and I'm really appreciating folks having ideas and trying to find ways to find funding. The federal situation, of course, isn't going to help that because that's going to make state funding even more competitive. But I think it's so important for California, and everybody's being really creative about how to adapt and how to bring in new things. And moving forward, continuing to think about what the new most important pollutants are, sort of moving more in that direction. I think so with PFAS is a really good example. The NTA's work is a really great example. I think this is where the program kind of needs to go. So I'm absolutely grateful to the Granite Canyon team and the State Water Board team for making this program possible and continuing to keep it on life support and moving it above that. And I think the work that's overall, I've had some questions and comments here. The quality of the work being done just feels amazing to me. I was very impressed at the presentations at the last conference, and have been really keeping an eye on the work over the years. And just I'm grateful to you all for doing this. So thank you.
Thank you, Kelly.
I would just echo that I feel, Bushra has done an amazing job keeping this program, moving in interesting directions, and the whole team at Granite Canyon that supports everything we do in SPoT and otherwise. We appreciate you all, and I think this program is moving in very interesting directions that we're excited about. So thank you.
Thank you. Yeah, we are thrilled to find new ways to leverage connections and do these analyses to support everything that the program needs to generate, all the partners, and just thinking of new ways within the constraints of the budgets and everything that we are faced with as a group, as a scientific community right now, to move forward and continue creating great quality data. So that's the goal. And thank you all for your time and all the inputs. I'll reach back out. Please feel free to reach out to me if there are any questions. This would be uploaded, right? I told Ashley and Rob. Okay.
Yeah, I can just add, we've been taking notes and we do have this recorded. And so we should have the notes and the recording posted for anyone to view in maybe the next 2 weeks or so.
And thanks, Tessa and Tony, for helping with all the questions and keeping everything on track. And it's wonderful to have you guys support our work and answer our questions and to keep everything moving forward. Yeah.
Yeah, thank you so much for all the good work. It's great to see this program continuing.
Thanks, guys.
It's nice to see what it's become too. It's been a long time building it. Bushra, if you have a moment, I'd love for you to show me where to find data on the Granite Canyon website. I'm hunting around.
Yes.
I'm not finding it easily.
Okay. We can just stick around and I can share my screen and show you.
Awesome.
Okay. Bye, Kelly. Thank you. Thanks for your time.
Bye, everyone. Great to
Bye,
see
everybody.
Have a good day, everyone.
Okay, so let me
Maybe stop recording.